Okay, so this is one of the examples of what we would call lateral spreading. And that basically means that the ground in the area of liquefaction is just spread like molasses running on a table. It's sort of spread out and spread into the rivers. And what you can see here, this area here used to be really flat. So the road used to be relatively flat, and there used to be probably about a half a meter high riverbank there. But this whole area has just flowed out into the river, and it's broken apart on these scarps. These little scarps like this, these vertical cracks. And so the problem here is that the ground is just basically flooded into the river, and it's lowered its flood banks all around. And so now we're out here in the rain. The river has been rising and rising, and it won't take a lot more for the river to actually overtop its banks into this area. And so that's a real long-term concern for those of us who are living here. It's sort of taken our vulnerability from, say, a 1 in 100 year flood or something like that to 1 in a 50-year flood, and it wouldn't be surprising actually if this is able to overtop those banks. And the other thing is that the trees have been stuck in the ground, but they've sort of fallen into the river a little bit, and as a consequence, some areas you can actually see the ground is being popped up as the trees fall into the ground. Now the river here has become both narrower because the banks have flowed into one another, and also shallower because there's a lot of sand in the bottom. So I showed you earlier, the suburb has gone down, the river channel has become narrower, and it's also become shallower because of all the liquefaction sand and everything like that in there. And all of that increases the possibilities of floods, or it all increases our vulnerability to floods. So it's something that a sort of a long-term effect of earthquakes has on these sort of areas.